All right, we are live.
Okay.
Good afternoon, everyone. We have Aniket Sinha with us. He's currently an undergrad. Got curious about the latest Python release and wanted to know more about the parser behind uh, Python. And today is going to briefly talk about the Python parsers. Uh, he he's currently a student and he's also part of several open source communities and mentors several students as well, and is also part of uh, analytics vidya.
Mm,
Henke.
yeah. Thank you, Parser, for the warm welcome, and welcome everyone to the PyConf Hyderabad. I know this time you might be enjoying the free Netflix, the fifth to sixth festival. But I appreciate you all coming up here and actually investing your time to learn some quality content about the product. Okay, so let's start with the parser. I just want to make sure that how many of you are interested in parser thing. Okay, just give me a emoji reaction so that I can know that yeah, you guys are interested in the parser and want to know more about it. Like you know, so yeah, I can few see emojis right up there. Thank you everyone. So let's get started. Okay. So in this session, I'll be talking about the PG parser. So the PG parsing expression grammar and why the unambiguous parser. I'll be discussing it later at the end of this slide. Okay. So hey guys, I'm Aniket. I'm a Python developer. I do an open source enthusiast, and I'm currently in my pre-final year at Manipal University, Jaipur. So yeah, that's about me. So before starting this session, right, I just want to make sure that you know the basics so that we can sync with each other. Like I am talking this and you're getting the point which I'm able to present you. So what we'll be talking the basics. We'll be talking about the compiler. We'll be talking about the interpreter, parser, LL1, ambiguity in LL1. Okay. So for most of the Python developer out there, you know these things are like the black box. Python developer don't care about this thing, like what is going on in the inside. Uh, as long as a plus b, like 1 plus 2 is giving you 3, it's working fine, right? So, but very less people actually go forward and dig up the what's going inside that, how it works and all, the token thing, the parsing thing, compiler, interpreter. Okay, so that's the thing. So I'm gonna in this slide I'm gonna tell you how does a Python program gets executed. Okay, so there's a compiler. Okay, you have a source code which is written. Basically, we all know a basic hello world program, right? The print hello world, and what a compiler does is it's compile your source code into a format known as bytecode. Okay, so basically, what it is doing is it's translating your code. Now, what's a bytecode? It's a low level. Okay, it's a very low level, platform independent. You can say the code, and yeah, so that's about the compiler. And next thing we'll be talking is that a compiler in Python. So what I previously talked was a compiler in general, but what does a compiler do in Python? It's that it converts .py source file. That's a you save your file like something .py into a .pyc bytecode. Okay, now this bytecode, it's as I said, this is a platform independent, right? It's a low level and a platform independent, and it's an intermediate. Okay, now this bytecode can be compiled by another, like it can be compiled by various, but I will talk about this later. Okay, so for now we'll say that it is passed on to the Python virtual machine. Okay, an interpreter execute this bytecode on the Python virtual machine. So as soon as it is passed into the Python virtual machine, PVM, as we said, so what it does is that it is executed by the Python virtual machine. So for those who are not understanding what's a Python virtual machine, it's a big loop. Okay, you can call it a big loop that iterates your bytecode that we have passed. Okay, the .pyc over and over and execute all your 1 byte code instruction, whatever the operation you have to carry out. So basically, it's a runtime engine for your Python. Okay, so this is the last thing. It's a now this is the basically the working of an interpreter. You have a source code is passed on to a compiler. Now a compiler converts this source code to a bytecode, as I said. Now this bytecode is passed on to the virtual machine, Python virtual machine, right? And along with the library modules, so like whatever modules you have included, you actually get a running code, right? So this is how it gets executed. Okay. Now I'm just gonna take some example here. Okay, now this will be a little bit of tough for you guys. Okay, there's an input. Okay, input in the sense, let's say for example 1 plus 2. Okay, this is the input we have given. Now, for this input, what we do is that there is a lexical analysis. What happened in lexical analysis that these are broken into tokens. Now, for tokens, we can say that 1 plus 2. Okay, so this can be broken into 3 tokens. As you can see up on my screen, that we have some spaghetti with eggs on, and we have all that things, and these are broken down into its smaller component. Okay, now these are broken down to like you can see all the ingredients, and we have syntax analysis. After syntax analysis, there's a parsing tree, the abstract syntax tree, which is formed, and finally we have the code generation over here. Okay, so that's how your program is broken down into tokens, and these tokens are converted into a tree. And these tree is finally, we get a one. If we finally get an abstract syntax tree, and then we get an output. Okay, so simplifying the process for you, I again want to say this is the how it works. Source code, bytecode, Python virtual machine. So previous all these slides we have discussed how basic like a small is broken down into tokens, and then we are okay. I hope you're able to. Okay, cool. Let's start with the next slide. All right. So there's various compilers and interpreters which are available for Python. Okay. This will be there's a Python, C Python. I mean, so these are the implementation of the Python in the programming language C. Okay. There's a Jython, which is the implementation of Python interpreter written using Java programming language. So as I said, that once you have the bytecode, these bytecodes are platform independent code, and these can be executed on other machines as well. Okay, like you can convert these into the Python or like the Java or the C. So that's how it goes. So yeah. So let's understand the parser thing for you guys. Okay, it's a command interpreter. Okay, it interprets the command, or you can say in basic language it breaks the source code, whatever is of print hello world, into a much smaller data, and it is a part of a compiler. Okay, now there are two types of parser: top down or bottom up. Okay, throughout this presentation we'll be talking about the top down. So what's a top down? Basically passes top down we discuss. So let's take an example here. Okay, for that we have the character on the chrs sp is equal to 100. Okay, it's just an example to explain you what is how does a parser work. Okay, so as we see in the previous slide, I told that the spaghetti was broken down to its ingredients. Okay, there was an eggs there, there was we basically make all the ingredients which were involved to make that delicious dish, and we have broken down into the small data. Okay, so here we have data. Sp is equal to sp, one token, equal is another token, 100 is another token, and yeah, there's a semicolon here. First, just ignore it because I know you're a Python developer. There's no need for semicolon. It's just an example to show you what a lexer does. It does a breakdown to tokens, and this system is like pretty much same for all the programming languages. That's how it goes. And what does a parser do? Okay, parser takes that tokens. Okay, all your tokens are taken and it is broken down, and all the broken tokens, and it forms a syntax tree. You can see over syntax tree here that sp is your equivalent expression and semicolon. Okay, so these are the syntax tree which is formed. Okay. Now I'm going to talk about the single token look ahead. So look ahead means looking at input tokens without moving the input cursor. Okay. So I will go one slide back. Okay. Suppose you're reading SP is equal to 100. Okay. So single token look ahead is like what comes next after this equal sign. So for single thing, okay, we are not, if there would be two token look ahead, we would be looking at 100. Your current cursor is like you currently read SP. Okay, but you're looking at what 100, because I said that you're looking two token ahead. I've just taken example. So in a single token look ahead, what we're doing is that looking at input token, okay, without moving the input cursor. Input cursor is currently where you can say where it's been in this SP, as I said that you have read this and you want to know what comes after this. So that's how it goes. And so which one uses the single token look at LL1 grammar? Okay, so there's an LL1 for most of you guys. It's a parser. So that's all you need to know about it. So what it does is that it uses single token look ahead thing. Okay, and that's the source for the ambiguity. Okay, that's the source for the ambiguity, because now I'm going to talk about in like the unlimited look ahead. Okay, unlimited look ahead, that's the speciality of the parsing expression grammar. It can look, beyond what LL1 person LL1 grammar, or it can look. Okay, so that's the thing. So as I explained, this one look at token means that you have to read the next character from the current character you're reading. So okay, so as I said that you're reading the name of the character. Now what you're reading is the equal sign. So that's how. Um, Starting with the basics of grammar. Okay, I know we cannot dive into the PG without knowing the basics of the grammar. Just like let's take a quick refresh our brain with what does an grammar looks like. Okay, so for every language, okay, so as you know that you have learned grammar in your as you enter the school, they teach you about the sentence thing. Okay, they tell you that use the noun and then verb and noun phrase. Okay, so a noun is made of an like let's say a noun phrase is made of an article and a noun. A verb is like what uh, we loves, hate, eats. These are an example. An article is a, the, and can also come. Noun is so this. So for, as you know that to learn English language, okay, you learn about the grammar. Without knowing the grammar, you cannot construct a sentence. Okay, that's the importance. Same for the programming language. Without knowing the grammar, you cannot construct the basic, the basic example. Maybe you cannot print your simple addition program without knowing the grammar. And you can say without knowing the grammar, you cannot speak a single sentence. Okay, you, even though you're able to speak, but you can say it will be ambiguous. Okay, so let's talk about an example here. Okay, so for most of you guys, I will tell you that S is a rule. Okay, grammar rule something, and F is another rule. Okay, so for every rule, as I said that we had previously sentence is a noun phrase, verb, and a noun phrase. That's an example, and a noun phrase is composed of an article verb. So same here, we have taken an example. This is in term of programming. So we have S here. S is a rule of the ground name rule, and this can be rule description here, or it can be another rule. So S follow F, which is a rule. F follows another rule, which is, and it gives the rule says that it's an input symbol A. Okay, if it's an input symbol A, follow it. So let a person be the character you're reading. Okay. Let's suppose that percentage is the current character. As I said, the input cursor is on the percentage, and the input string to be a plus a. Okay. Suppose you're reading a plus a. So as I said, that percentage. Let's say how does a parse how it goes. Okay. We are just going with the grammar. We're talking about the grammar here. A plus a. Read the start of the string and look ahead is we see the percent sign here and we see a bracket. Now we start matching this bracket with a given rule. Which matches the rule? This one. No, yeah, rule to satisfy this. To yep, we will print the syntax tree for that. So we have S here, S rule one, and S goes to F, S goes to S, right? So S is composed of S plus F. Okay, F S is here written here S plus F because we have detected a bracket here, and we have the F S. We can see here F follows the third rule. We have composed A, and S follows another rule. Okay, that S goes to F and F goes to S. We have A plus A. So this is how your syntax tree is composed. So, to talk in a basic way, okay, the grammar is used to describe all the possible strings in a language. Okay, it generates all the string which is possible in a language, and it is also useful in specifying how parser should parse the language. It tells you the basic. Okay, now the next thing, if someone is interested, I will share this slides with you guys too soon. Okay, so if someone is interested in to go basics, you can follow the Python grammar. Okay, an example is 5 less than 2 plus 3 or not. This is just an example of the grammar. Okay, let's move ahead to the next part. So for the LL1 parser, which is the current Python parser, okay, our current Python parser is using the LL1, which is the, as you, if I break down the word for you, it is left to right, scanning left to right with the leftmost derivation and one token look ahead. Okay, see, so if you want to know about the LL1 parser, so what is does is that it does not fall. There's a certain rule to parse the language in the LL1. So we scan the input from left to right, and then go to the leftmost derivation, and then it's like looking at one token look ahead. Okay, I will tell you more. So the parsing expression grammar. Okay, so this was in the 2004 Brian Ford released a paper explaining the parsing expression grammar. Okay, which translate the extended back is now form to recursive descent with infinite look ahead. Okay, now as I said you, there is an infinite look ahead in the parser. Okay, so you can look at all the possibilities which is can be made. Mm, like you're not reading the equal to sign, you can go, suppose your expression is a is equal to a plus b, so you can go ahead to a, you can go ahead to b, because there is a possibility that we have infinite look ahead. Okay, so that's a thing with, that's a problem with the current parser. Okay, that the current parser which Python is using, the LL1, there's a big problem. So because it's producing, we cannot be more expressive with the grammar. I will tell you later why we cannot be more expressive in that, and there's a lot of ambiguous which is coming up with this thing. So why bother about the PAG? The parsing expression can be made to support left recursion and rules. Okay, more power, so grammar looks more natural. Okay, so there's a look ahead assertion as well. Now, for look at his assertion is that we can say that if this token comes, then this will be followed by the another token. Okay, so let's take an example of the ambiguity which is present in the LL1. Consider the grammar. So S, A, and A. Okay, so we have taken the example here. Uh, it's a basic example I've taken, which is present in the ambiguity of the we can say the LL1. Okay, so suppose we have a grammar. Let's take this one second slide here. We have a grammar S, and S is the rule here, and the rule state A and B. So what is here is that what if using a single token look ahead? Okay, we have common element in both A and B. Okay, you read A is equal to, B is also reading A is B is equal to. Okay, which one you will choose? Okay, which rule you will go with, A or B? That will be the point of ambiguity in LL1. And there's a this taking this example, S goes to A and A goes to A. Okay, so there can be a lot of possibility which can be produced from this grammar. Okay, now to when you're writing, suppose that you're writing a simple program, okay, one output, but this grammar is giving you a two output, okay. So that's in point of ambiguity, and as I said that as A and B, can have both element in common. We can say that A has an element and B has an element. Using single token look ahead, we got equal to sign, and even in B we got an equal to sign. Okay, so which rule you will follow, A or B? We cannot know, right? So that's a thing. We just call with a it's a recursive decent. We can say that it's a recursive decent parser. Mm, and each parsing function yields the following result. Okay, there's a two possibility which can be made from a page parsing expression grammar. Either the expression will be a success, as you can know, either you will be able to pass it, or you will not be able to pass it. Okay, there's only success means yep, the expression has been completed. You have the option, you can consume one more input and check. Okay, so like as I said, A is equal to A plus, so you got the equal to sign. It's a success, hooray. Okay, but and what you can do is just consume another input. Okay, so that's thing. What if it fails? In case of the failure, no input is consumed. A failure in this parser basically means try the following option. ये नहीं हो रहा तो ये कर. There's a there's a thing. So it cannot fail. The best thing or the parsing expression grammar, it does not and it cannot fail because it has the option. If अगर fail होता है तो कुछ और option he will do it. Okay, because there are all of rules set up in this thing. So I just want to tell you key difference between EBNF and PAG. Okay, EBNF rule. Let's stay this rule. Okay, the in a context-free grammar. Okay, this CFG is a context-free grammar. In that left recursion and right recursions are the same. So if we the EBNF rules AB slash A and AB are equivalent in CFG, but those rules the which I have written bold are not equivalent in CFG. Okay, they are different. So the second alternative is because we have used a prioritized operators. So if you see a hash slash sign, this is a prioritized operator which gives a priority. The second alternative in the later will never succeed. Okay, this will never succeed agar first choice detect ho gaya. If the first choice is A B, so it will not go to the second choice. Okay, so you can see if the input single string to be recognized begins with A, suppose a string begins with A, it will detect A here. Okay. Now, if A is detected, it will not go to the second alternative. We have the prioritized operator. Here we don't have a prioritized operator. Okay, so that there's a bit of ambiguity here. So more expression, I will tell you that E1, E2. So this is another concatenation. So looks for a match of even followed by E2. Okay. So suppose there is a two grammar which is written. Looks for a match one even. First expression is match followed by two E2, and if either failed, we are backtracking to the starting point. Okay, there's a thing about the in the parsing expression grammar. There's a backtracking. So if E2 fails, if you know about the famous and queen example here, it will pass back to the starting point. Like E2 fail ho gaya, so kya? So it will go back to the even. So if even in the any queen example, you can know about the backtracking. If the queen is, we just use a parser substitution, and if the queen is placed in a position where it is under attack, it goes back, it changes the position of the previous one. So it's like that. Okay, so there's an always a possibility we are getting a certain output, and that's okay. So this is in the parsing expression. The PAG formula gives a convenient syntax for describing top-down parser for unambiguous language. The parser it describes can parse strings in linear time. Okay, this parser is a specialty. It can parse strings in a very event time despite backtracking by using a memorizing algorithm called practice. So just go brief into the memorization algorithm. What you can see is it does is that it loads the entire program into the memory. All your program is loaded into memory. So yeah, that saves does consume a lot of memory, LL1, but basically it does perform better than it. Okay, the PG person does perform better than Prac, and it is done to avoid the time complexity here and to reduce it further. We are using the memoizing algorithm. What it does is that I told you it loads the entire thing into the memory. Okay, memory is quite cheap in the 2020. You can buy it. So
Hey, Aniket.
definition of a PG parser in simple words. I'll go with the. It describes a formal language in terms of set of rules. Okay, formal language in terms of set of rules. There is certain set of rules which is to be followed, and for recognizing strings in the language and in complex word. So this is the complexity of this. If you're a mathematical student, this is the definition which you'll be able to get for the PG parser thing. We have the four.
Hey, Aniket.
I'll just cover
Hello.
the few. Yeah.
Yeah, sorry, I just wanted to interrupt since we have 4 minutes. You have a couple of questions. So
Okay.
once you take them, you can come back to the presentation. Is that
Okay.
okay?
Yeah, sure.
Yeah. So the first question is, why do we need a compiler of Python? I mean, if Python is an interpreted language, that's the first question.
So interpreted in the sense that, as I told you, that the you have a parser thing. Okay. As I told you in the further slide, that Python source code is broken down into the bytecode. Okay. Bytecode. Now this can be this is I said uses bytecode can be interpreted using an interpreter. Okay, there's a the interpreter. Now this interpreter, what it does is that using the LL1 parsing, we convert the .pyc into the source code you are using. Okay, so that's a thing about this. There's a use of a compiler. Because as I said that okay, can we use ANT layer to generate compiler or interpreter? So yeah, there's okay. I will just take this example. Like ANT was taken into consideration 30 years back. Okay, but if you read some article about the by the Guado and Rusum, there was a possibility that we can. There was he was trying to like using ANTLR as an interpreter. So yeah, there's a possibility to use that as a interpreter. But due to certain reason, it was rejected. I don't know what, so it was rejected back then. Shall I continue with the slides if it's okay?
Yeah.
So there's a basic rule. PG will check if the first alternative succeeds and then it moves ahead. So if A succeeds, then it moves to B. B succeeds, then it moves to C. These are the rules of the grammar. It's unambiguous. Like if a string passes, it has exactly one valid parse tree. Okay, when you're doing a parsing tree, it prints you the one valid tree. And there's a recursive decent parser. Okay, recursive decent in the sense that every rule in the grammar, there's a rule for that. Okay, all the function in the program, in which every rule in the grammar correspond to a function in the program. Okay, so we have a rule grammar A. Now A will correspond to a function here. B will correspond to this function here, implementing the parser. And as I said, there's a packet parsing. Okay, the packet parsing in the sense that load the entire program in a memory. Okay, your entire program is loaded into memory before it allows the parser to backtrack, as I said previously in my slide. So these are the properties. I guess we have this time. So I'll just get into this. So yeah, this is one of the interesting thing I want to talk about. That the speciality of this thing is that it eliminates the repetition operator. Okay, there's no as in CAG. There's no possibility to produce empty strings. So any repetition can be eliminated by replacing it with a non-terminal A. As you can see, the in the if you know about the grammar thing, the repetition is using a star symbol, and it is eliminated using a non-terminal A with a definition this. Okay, so what is the advantage? It is powerful over
Hey,
time.
Aniket, we have one more question. How does
Okay,
this differ from LLVM?
uh, LL LLVM, right? How does this differ from the LLVM parser? I currently not much. I will be honest with you. I have not much experience with the LLVM, right? So this.
Yeah, that's fine. You have other
It's okay
comment?
if it's because I know about the LL1 parser thing, and so if it's not an issue with you guys, I'm not pretty much experienced with a lot of different compiler. I know about NTA, NTL exist, LL1. So what you can speak about the PAG is that it has an infinite look and took ahead token. Okay, there's a lot of possibilities we can look ahead, so that avoids the ambiguity. And another thing is that in this the PHP there's a backtracking. Okay, there's a level of backtracking and the memoization algorithm, which is the packet algorithm. Okay, so these are the things which makes the parsing expression grammar. With the infinite token look ahead, you have the possibility to generate a lot of to go ahead and see that yeah, this can be done. This using a single token lookup, as I said, there can be common element in both A and B. So it can gets confused in the parser itself. Like, what should I choose? Which rule should I go ahead with? That's the thing. The PG avoids this. So using the infinite token, it goes one step ahead and like, let's go one step ahead and check this. If still there is common, it goes another step ahead. Let's check common until the point it's able to differentiate between the two rules. That's the thing about it. I'll just quickly wind up. Okay, 2 3 minutes.
Okay, Aniket, sorry, we are out of time.
Okay,
Thank
okay,
you so much for your lovely talk.
okay,
And I thought it was great to know about the backend of Python.
okay.
And please do hang around in launch. Maybe some of the attendees would like to have a word, maybe discuss about passes.
Hmm.
And thanks again for joining. Please do hang around for the next
Thank you,
session.
thank you,
Thanks, Aniket.
thank you.
You have a request to share the PPT from Priya
Yeah,
Pratap.
I will share the PPT. Here itself, right?
You can
I
share
will
under the
share it on
event
the
tab.
Zulip. Okay, I can share it on over the Zulip because I have not
That
uploaded
works.
it over the online. So for the PPT thing, I will share it over the Zulip chats, and you will be able to access. Okay. So thank you, everyone. I hope to see you.
Yeah. Thank you. Bye.
Thank you. Bye.